Good morning and welcome to this webinar where we will talk about the most common analytics modules used in the Crosser solution, why and how. My name is Goran Appelquist and I'm the CTO at Crosser and will be your presenter today. Before we get into the actual content, just quickly about the webinar tool. So there are a couple of sections on the right-hand side that you can use. First, there is a chat that you can use if you have problems with the presentation, connectivity issues or something like that. Then just use that and we will try to help you resolve that in the background. If you have questions, you can use the Q&A section to write questions anytime during the presentation. And then at the end, we will try to answer those questions that you have entered. And the slides that I will use today, they are also available in the handout section for download if you want to have them on your own. So let's get started. First, quickly about Crosser. We're a Swedish software company based in Stockholm and also with another office in Sweden, and we also have presence in Germany. Founded in 2016 and focusing on edge computing or edge streaming analytics for different types of real-time integration and automation use cases. And we target primarily different industrial use cases, both factory floor use cases and machine builders that wants to enhance their offerings with analytics capabilities. So basically any type of asset-rich industries where you generate data and want to do something with that data close to the source of the data. So in this presentation, where we will talk about some more details, specific modules and so on, assumes that you have some previous experience of Crosser. So I will not go through the whole Crosser solution in this presentation today. I assume that you have heard at least something about Crosser, but just to put it in some perspective for those of you that haven't. Crosser is about collecting and processing data close to the source, wherever that might be. It could be on a factory floor, on a machine, on a mobile asset, out in the field somewhere, or underground, even if it's a mine, in your local data center, or even in the cloud, if that is where you have your data. That's also a possibility. But it's all about collecting and processing data close to where the data is originated. So that's what we talk about here. And when we design use cases for these different applications, we use a low-code tool where you combine pre-built modules into processing flows or data pipelines like you see on this slide. So this is a typical flow where data flows from left to right. So you start by adding your input modules to collect data from your sources, then modules to do something with the data, and finally you use output modules to deliver the result to wherever that is needed. It could be back to the machines where you collect the data from, to some on-premise system, a database or an ERP system, or you want to send data up to the cloud, either to your private cloud or using some SaaS service that resides on the internet, like if you want to send the text messages or emails or something like that. All of these options are covered by these modules that are provided by Crosser. So we offer a module library that you use as a starting point for building these type of flows. And the reason behind this is that we have tried to minimize the need for software developers when implementing these type of use cases. So by combining these pre-built modules, you don't necessarily have to write code. In some cases, you want to do that, and that's also a possibility, but many use cases can be solved without writing a single line of code. So that's the sort of underlying principle of the tool suite that we offer. And there are several advantages with doing this, not just minimizing the need for software developers. These type of use cases typically involves different skill sets in order to set them up correctly. So if we look at the example that we have on the screen right now, on the left-hand side, we start with input modules that connects into machines. In this case, it's a PLC connector, an OPC server connector, and an MQTT input that receives data from some sensors. These systems are typically managed by the operations staff. So you typically need input from that side to correctly configure and set up these input modules. In the middle, you do something with the data, and depending on a little bit what you do, you might do that on your own. But if it's more advanced use cases, you might want to involve your data science team to get the algorithm correctly specified. And on the right-hand side, where we deliver the results, we typically connect into systems that are managed by the IT staff. And having this kind of visual tool where you can see the whole flow is a great way of getting all these different skill sets working together to solve an actual use case. It's also a great way to explain to non-technical staff what you're actually doing at the edge with your data. So there are several reasons why we have decided to use this kind of programming paradigm for our tool set. But the focus today will be on the modules that are used inside these flows when you build them. So at Crosser, we provide a library of modules that implements common functions that we see in the type of use cases that are built using our tool for these different type of applications. So this library, which today is something like 120 plus modules, covers all the different functionalities that you typically need, starting with input modules to collect data from different sources. Could be PLCs, sensors, files, databases, APIs, and so on. Whatever type of source that you want to collect data from, you should find a module in the library to help you get data in to one of these flows. And then the first step is typically to do some kind of transformation of the data, because it's not very common that you get data in the format that you want or need. So there are modules then to help you manipulate data formats and transform data in different ways. And then you might want to do some processing on the data. Not always. In some cases, it's just a question of collecting and transforming data into some useful format and then send it on to some other system. But in many cases, you want to do something with the data already at the edge. And that could be anything from basic condition logic all the way up to running complex algorithms or machine learning models at the edge, which is also possible with this solution. So there are modules to help you with that. And then finally, once you have derived some results or insights out of your data, you want to send that somewhere. So then there's also modules to connect into different destinations, which again could be on-premise, could be sending data back to the machines where you got the data from, sending data to a local database or some other system like an ERP system, or sending data up to the cloud. So this is the whole library that is offered by Crosser. But today, we will focus on these modules in the middle that are used to actually do something with the data. So we will not talk about the input and output modules to talk to the external world. We will focus on these modules in the middle. We call them analytics modules. And what we have done is that we have looked at what our customers are doing with our tool, how they are using these modules. We have looked at all the flows that they have built for different use cases. And then we have ranked the modules based on the number of occurrences that they have in our customers' use cases. And based on that ranking list, we have then picked the 5 most common used modules. And those are the ones that I will talk about today to help you understand how this tool is used and why these modules are the most popular ones, so that you get a better feeling for the type of problems and solutions that you can manage with this tool. Before we get into that, I just wanted to bring up another slide that I think some of you might have seen if you have followed these webinars that we present, and you can also have seen it in other places. It's a common presentation of the journey that you typically need to take with data. So it's a pyramid that covers the steps that you typically have to take in order to get from your raw data at the source to some insights further up in the pyramid. And what it tries to explain is that you you have to sort out the lower layers before you can move on to the upper layers. So you cannot start with machine learning, for example, if you haven't sorted out your data formats and naming and structure and so on. Then you will definitely fail. So there are a number of steps here, starting with collection at the bottom. Getting access to data is, of course, crucial. You need to be able to get access to the data wherever that is originated. If it's a machine or a database, doesn't really matter. You need to have ways to get data in, and then start working with that data. And the first step is usually, as I mentioned, transforming the data in some way so that you can use it. It could be that data just arrives in a format that is not suitable for the processing that you want to apply, but it could also be that you're getting in data from multiple sources and they deliver data in different formats. You need to harmonize data across these different sources so that you then can use it as a single stream of data in your processing. And then start to add more logic and processing on top of that, and then eventually get into the top layers where you do more advanced stuff like machine learning and the custom algorithms. So the idea with the Crosser module library is to cover all these steps in the pyramid. So wherever you start and wherever you want to go, the module library that we provide should be there for you to help you take these steps and derive the insights that you want from your data. So let's get started with the actual modules. So we start from the top with the most popular module. And that is a module that we call the property mapper. So this is I've called it here the Swiss Army knife of data transformation. So this is a module that you can use to restructure data in different ways. So you can introduce structure if there is no structure. You can change the structure to whatever you need. You can align naming conventions. You can add metadata to your data. And so on. So this is a module that operates on the structure of data. It doesn't do anything with the actual values that you have in there. It only operates on the structure. So this is by far the most popular module that we have in our library. And why is that? I think you've already guessed that based on what I said in the introduction here. In principle, every use case that we see, you need to do some kind of restructuring of your data, because it's very uncommon that you get data in a format that can be used right away. You typically need to do something with the data, restructure it in some way so that you can actually simplify your processing and start using it. And then, as I mentioned, also another use case is that you get data from multiple sources, or you want to use data from multiple sources, and then it's very uncommon that these formats are the same. So then you want to restructure and harmonize the data from these different sources so you can treat them as one stream of data and don't have to worry about the differences in format when you start processing the data. There is actually one more reason here, which I didn't mention, and that is on the output. If you have a flow like the one I showed you in the previous slide, where you have multiple outputs, it could also be that these different destinations require data in different formats. So you might need to have to restructure data on the way out as well. So this type of operation we see in basically every use case that our customers have built, and that's the reason why this module is number one. And the way that you do that in this module is that you define mapping rules. And there are three types of mapping rules that you can define. There is what we call move, which you use to move an input property or a property that you have on the input message to a new property in the output message. And that move operation could be just moving it to another name, i.e. renaming it, but it can also be moving it to another hierarchy level. So you can move it to a new level to introduce hierarchies. You can move it upwards to remove hierarchy levels. So you have full flexibility there in operating on the hierarchical structure of the message. Second type of rule is the remove operations, which I guess is obvious. Then you can take away data from your input message so it doesn't appear in the output, which is also quite common. Usually you get a lot of additional metadata on your input that you're not interested in. Then you can strip out that at the input so you don't fill up the pipeline with a lot of data that you're not interested in. And finally, you can add new properties or new values to your message. For example, adding information about where this data is originating. Maybe like I've done in the example here, we added the machine type property to specify from which machine this data was captured. Maybe that is not part of the data that you receive, but you know that because you're running this in a specific location, so you know which machine it's coming from. So you want to tag the data with this additional information to make it easier to manage it further down in the processing pipeline. There's also another use case where you can create more dynamic message properties, which is the lower example in the picture here. Well, let's first take the first example. I should cover that actually. So in the top example that you see here, then we receive data without any structure. It's a flat structure with 6 different values of some different types. So what we've done here by setting up some rules is to create some structure. So we combined all the location information into a new object called location, and then we have all the information there, both position and the name of the location. And we collected the actual measurements into another object called measurements, where we put in those 2 values that we got from sensors. So we introduced some basic structure into this message, and we also added a new property to specify which type of machine this data is coming from. So this is one pretty common example, pretty basic at this stage, but I guess you get the idea of what type of operations you can do here. But then the second example here is showing another common example. If you get a stream of data from multiple sensors through some input like MQTT, for example, you typically get messages with this type of structure you see at the bottom, where each message has a name indicating the source of the values and then the actual sensor value. And then you can get any number of sensors through the same input with just different names and values for each of the messages. But let's say that you want to combine multiple sensor values into a single message. So you want to combine these 2 input properties into one, where the name of the sensor is the property name, and then you assign the value to that new property. That type of combination can also be done with this module, and that's a pretty common use case where we see this module being used. So this is the first and I think not so surprisingly number 1 module in our library, since this is common across almost all use cases. We were not that surprised that this was the most common module. When we get into the second module there, it was actually more of a surprise, and to be honest, also a bit of a disappointment from our point that was the case, because the second most popular module in our library is this one called Python Bridge, and this is a module that allows you to run your own Python code as part of a flow. So within this module, you can plug in your own Python code and run that as part of a flow. And then you can ask how come a code module is the second most popular module in a low-code tool like Crossers? And that was, of course, the question we asked ourselves when we saw this. So we had to look into all the different flows that customers have built to really understand what have they been doing with this Python module and how come this is such a popular module. And the conclusion, and I think the reason why it made it to the number 2 position in the list, is actually the first bullet here under why. Because we think that a lot of our customers knows Python, so they know how to write Python code. And when you're new into this tool, you don't really have all the knowledge of the available modules in the library and what they can do. it's a lot easier to just write a few lines of Python code to do what you want. So what we've seen is that a lot of these Python modules, they are used to do things that you can actually do with the fixed function modules that are already available in the library, and in many cases actually transformations that you would typically do with the property mapper module. So this is why it ended up here, and that has of course triggered us to change the way that we present stuff and how we help our customers to find the right modules in the library. But on the other hand, I mean, there's nothing wrong in doing that. If you prefer writing Python code to using fixed function modules to solve your problem, that's fine. I mean, the most important is that our customers can solve the problems they have at hand. There are some disadvantages, though, in doing it like that, because you lose some of the advantages that I talked about when we looked at the flow earlier on. I mean, that you can see what is happening by looking at the flow. That part, to some extent, disappears if you start using a lot of code modules, because then you have to open up these code modules and take a look at the code to actually see what is happening. So you lose some of that visibility that you get with this type of graphical design tool. And also there is some performance impact of using Python for doing simple things. If you start up the whole Python engine, that is of course not as efficient as using a fixed function module that is optimized for that specific function. But if you're okay with that, then why not? I mean, we don't really put any opinion on that, so that's perfectly fine. But then the other two reasons why this is a popular module, and also actually the reasons why we added this module to the library from the start, is the next two ones here. So with this module, since it allows you to run any Python code and you can also install any third-party libraries, it's a perfect platform for running your machine learning models. Because most of the machine learning models that we see today, they are built and trained using one of the Python machine learning frameworks. And to execute those models, you typically need to replicate the same machine learning framework at the edge and then load the model into that framework, whether that is TensorFlow or some other popular machine learning framework. So that is a very good use case for this module. So you can load your favorite machine learning framework, use that to write some wrapping code around your model, load the model file, and then feed it with data from your flow. And then use other modules from the library to collect and prepare data so it's suitable for being used inside your machine learning model. Same thing with more advanced algorithms. In some cases, our customers already have some kind of algorithm that they want to apply on their data. And if that algorithm is written in Python, then of course it's very easy to just plug in that Python code inside this module and run it, and then use the other modules to prepare the data. But the actual algorithm is running in this code. And in that case, this makes perfect sense. If you already have the code, I mean, there's no reason to redesign it using a lot of standard modules. So these are the three main reasons why this module is such a popular module. So let's move on to number 3 on the list. This is a simpler module, but still a very common module. It's called text template, which I guess explains what it's doing. So this module is used to create dynamic text messages where you can combine static text with data from your messages. And there are two main use cases where we see this being used. One is because a very common scenario is that you want to create notifications. You have defined some condition that you want to monitor, and when that condition triggers, you want to send a message to someone to inform them that something has happened, and you want that message to be a human readable message. You want to create some kind of text message, and then this is a perfect module for that. So what you do here is that you in the module, you create a message using a template syntax. So you can insert data from your flow messages into the text message, like you see in the example here. So we have some text where we insert two values from the message, and then we create a message like you see on the right-hand side. So this is one common use case for this module. The other use case is when you want to combine multiple string values, or could even be numerical values, but in most cases it's actually string values. You need to combine multiple string values into a single value. And this could be, for example, when you communicate over APIs, where you need to create specific values based on multiple input values that you have, or you want to build things like topics for your MQTT broker to communicate correctly, and those topics should be dynamically created based on data that you get from your data sources. That's another use case where that could come in handy. And also when you work with APIs, in some cases, these APIs require that everything is sent as a string, including numerical values. And then you can also use this module to convert any numerical value into a string value. So that's yet another use case. So there are several places where you need to manipulate string data and combine them in different ways. And that's why this module is so high on the list. Next one is the timestamp module. And this module has two purposes. First of all, you can use it to add timestamps, so you can add the current time to data. And the second use case is to convert timestamps between different formats. And that also explains, I guess, why this is such a popular module. Because in many cases, when you receive data, there is no timestamp. You don't know when this data was captured. For example, if you get data from a PLC, there is no timestamp associated with that. So in many cases, then you want to add the current time to the data so you know when it was captured. In some cases, you do get timestamps with your data, but it's not in a format that you can use. Maybe you need to send this data to some API that requires timestamps in a specific format. So then you can use this module to convert incoming timestamps to whatever format that is required by your destinations. So that's two very straightforward use cases, but very common. And that put this module in place number 4 on our list. So this is also a very common use case. And then finally, I cheated a bit by actually adding 2 modules here at position number 5. In reality, it's the module called Array Split that ended up on position 5. But since these 2 modules are very often used together, I decided to put them in here, both of them. I think the join module was at number 7 or something like that, so it's very close. But these modules are designed to work with arrays. So the split module is used to break up an array into individual messages, and the join module does the opposite. It takes a stream of messages and combines them back into an array. And the reason why these are common is, of course, because arrays are a common format being used when you have multi-sensor data. If you get data from a PLC, for example, or through an API, you often get multi-sensor data in one big message where the different sensor values are presented as an array. But if you want to do stream-based processing on those sensor values, stream-based processing is based on having one sensor or one value per message so that you can operate on them. And then these modules come in handy to help you with that. So with the split module, you can break up an array into individual messages, then apply some processing on these messages, and then with the join module, recombine them into an array again, if that is needed. In some cases, it might not be needed, depending on what you want to do with the data. But if you use both modules, they actually communicate with each other so that the join module can recombine the same array that you started with without having to know anything about the size of the array and so on. So with these 2 modules, you can build use cases like looping over an array that you typically see in programming languages. So this is what that would look like in a streaming environment. So you start by breaking up the array into a stream of individual messages and then recombine it back to an array. So using these 2 modules, you can go back and forth between array-based and stream-based formats, which occurs quite often when you want to build different types of use cases. So this is the last one that I wanted to cover today. And before we end, I just wanted to show you a real use case where we have used almost all of these modules, but to build an actual use case. So I've used this one, which is maybe straightforward. It's just one input, but still, I would say a quite realistic use case. So we start by getting data from a PLC. So we haven't covered input modules, but this is a PLC input module getting data from a Siemens S7 PLC. So here we get data as an array. We read multiple registers in this PLC and get data as an array. There is no timestamp with this data since the PLC doesn't provide that. So we start by adding a timestamp with the current time to the data so we know when it was captured. And then we want to do some manipulation of the data. And what we want to do here is both to convert all the temperature values that we have in that array from Fahrenheit to Celsius. And we also want to adjust the naming a bit in these messages because it's not aligned with what we need. So we use the array split and join combo to break up the array into a stream and then apply this processing. And since we only want to convert the temperature values, we have added a filter on this mathematics module that does the actual conversion. So we filter on the name because there's a naming convention on the temperature sensor values. So they all start with the same name or same string in the name. So we can use that to filter out. So we just process the temperature values and leave the other ones untouched. And then we recombine it back to an array because that is what we want to then feed into a machine learning model that we run inside the Python module. So we get the new array with values each second that with new data from the PLC that we then feed into the machine learning model. And this is a model that is designed for optimizing the performance of our machine. So the output of this will be a new setting that we then want to send back to our machine, again using a PLC connector to deliver the result back to the machine. So this is one example of how these type of modules can be combined to create a real use case, which is more or less what we see out there being built with our tool. So to summarize, as you might have seen already, based on the modules that I presented, data transformation is by far the most common thing that we see across all use cases. There is in principle always some kind of data transformation needed in every use case, and that's why you see so many of these modules that operates on the structure and type of data that you have. Also, as we saw with the Python module, being able to run custom functionalities that are not offered by the standard library that Crosser offers is crucial with this type of tool, so you don't get locked in and can only do the things that are offered by standard modules. And then also there is, of course, a learning curve when you start using a tool like this. It's an extensive library, lots of different functionalities that can help you. But when you start, of course, there is a threshold that you need to pass before you fully understand and can utilize the libraries to its maximum capability. But we definitely think that it's worth spending that time. And we see that with customers that has taken that step, that they start to build much more efficient and easy to use tools that will help them manage these tools also over time when they need to make updates. So this was a very quick intro, but if you want to learn more, then don't hesitate to get back to us to either schedule a personal demo where we can look into more details. You can also sign up for a trial if you want to get your hands on the tool itself and try it out. And we also offer free online training courses that you can sign up for to learn more about what you can do with the Crosser solution. So with that, I reached the end, and I will see if there are any questions that we should answer. Yeah, it's really not a question, but more a comment, and I fully agree with that. So it's about the Python Bridge module and that being the second most module. And the comment was that this is common to programmers. They prefer their own written code to combining different modules, even if they could achieve the same results. And I fully agree with that. We see that as well. If you are a programmer by heart, then writing code is your first choice in most cases. And there's nothing wrong with that. I mean, that's perfectly fine. And we even have customers that use our tools as a way of deploying their code, because that is also something we haven't really covered today. But I mean, the deployment tools that you have with Crosser makes it very easy to deploy your own code in many distributed locations and manage that over time with upgrades and so on, which might otherwise be a challenge. So that's definitely a use case. We got another question here. How can I measure ROI by implementing Crosser? How industries improve their productivity, production, save money, etc. Well, you don't really, I guess you don't really measure ROI directly with Crosser, but you can definitely use Crosser to provide you inputs to that ROI calculation, either by calculating different KPIs and so on. In principle, I mean, if you have all the data, I guess you could also implement the actual ROI calculation. We haven't seen any customer doing that, but it's of course a possibility. But I think a more natural use case would be to provide the input to those type of calculations based on the data that we see in our solution, like KPIs, for example. So it could definitely help you with that. But then I think you probably need to use outside calculations to summarize the ROI, because that needs information that is typically not available at the locations where we sit. But if it is, then it's of course possible. Okay, looks like we have no more questions. So then thanks everyone for attending, and looking forward to see you in the next webinar. Have a great day.